GPT-5 estimated 2 to 5 trillion parameters. Your brain, 100 trillion synapses. Everyone throws around 70 billion parameter model like it means something. But what actually are those 70 billion numbers? Here's the simplest explanation you'll ever hear. A parameter is a single number that stores a tiny piece of learned knowledge. That's it. One number. Like 0.0023 or negative 1.47. When someone says 70 billion parameter model, they mean 70 billion individual numbers. Let's make this concrete with a chai analogy. Imagine building an AI to make perfect chai. Version 1 has just one parameter, put 2 spoons of sugar. That's the entire model. One decision, same chai every time. Now version 2 has 6 parameters, sugar amount, milk ratio, tea leaves, water volume, boil time. Suddenly the AI can make different chais for different people. More parameters means more nuance, more decisions, more intelligence. In technical terms, parameters are called weights. They live inside the mathematical layers of a neural network, in the self-attention layers, the feed-forward networks, and the embedding layers. Every single number in every single matrix is a parameter. So where do all 70 billion numbers physically live? Each parameter is stored as a 16-bit floating point number, that's 2 bytes. Do the math, 70 billion times 2 bytes equals 140 gigabytes. That's why running a 70B model requires serious hardware. Here's the key insight: nobody writes these numbers by hand. When a model is first created, all 70 billion parameters are set to random values. The model is a newborn. It knows absolutely nothing. Then comes training. Show the model the cat sat on the blank. It guesses banana, wrong. Calculate the error. Nudge the parameters slightly toward the correct answer and repeat. Billions of times across books, code repos, and scientific papers. Each update is tiny. One parameter goes from 0.4721 to 0.4719, a change of just 0.0002. But multiply that across 70 billion parameters and billions of training steps, and you get a model that writes code and explains quantum physics. Does bigger always mean better? Mostly yes, but with diminishing returns. OpenAI's 2020 scaling laws showed that doubling parameters gives consistent improvement, but not double the performance. And training data matters just as much. A 7B model trained on 2 trillion tokens can beat a 13B model trained on 500 billion. Now the practical problem: VRAM. To run a model, every parameter must fit in GPU memory. A 70B model at full precision needs 280 gigabytes. At half precision, 140 gigs, quantized to INT4, and it shrinks to just 35 gigs, plus overhead for attention cache and runtime. Quantization is the art of making those 70 billion numbers smaller without losing too much intelligence. INT4 quantization shrinks a 70B model from 140 gigs to about 35, making it runnable on consumer GPUs. It's a trade-off, small accuracy loss for massive memory savings. One last thing, don't confuse parameters with. Parameters are the 70 billion numbers the model learns automatically during training. You never touch them. Are the handful of settings humans choose before training, like learning rate, batch size, and number of layers. So here's your cheat sheet. 70B model equals 70 billion learned numbers, not magic, just math. Bigger models need more VRAM. Training data quality matters as much as size. And quantization is your best friend for running big models on real hardware. Now you actually know what those billions of parameters are.